start doing some inverse type things today. Okay? So in order to do inverse type things today, we first have to take a step back to when we were all younger and we were in the Alg 2 form of class. Okay? Talked about inverse functions in Algebra 2 extensively. Okay? What we did, what the process that one goes through in order to find the inverse is we switch the x and the y. Okay. So we flippity-floppity x and the y. That gives us the inverse. Or if we have the inverse and we want to find the function, we flippity-floppity and we solve for y. Okay. So if I have the linear function y equals 3x, a line that goes through the origin with a slope of 3, the inverse function of that would be x equals 3y, or more simply, y equals x divided by 3. Yes? My synopsis, right? Isn't it synopsis in your brain? Reconnecting, making connections, making statistics count. Party Sabetti. Everybody loves Party Sabetti. Okay? Y equals x plus 7, or a line that goes through 0, 7 with a slope of 1. Okay? So I'd flippity-floppity. And so I'd get x equals y plus 7, or y equals x minus 7. Yes? Yes. Yes. Okay. If I had a quadratic function, y equals x squared, I would flippity-floppity, and I would have x equals y squared. And then the inverse, y equals the square root of x. If I wanted to keep it being a function, I would just have y equals the square root of x. Truly, it should be y equals plus or minus the square root of x, right? Okay. But then that's not a function. Okay. But truly it is that. Exponential type, y equals 3 to the x power, same thing, flippity-floppity, x equals 3 to the y power, or y equals log base 3 of x. Now that's all good and good for functions, but we live in the pre-calculus world where we have trig functions.
I'm so excited.
Yes. Okay. So what do you think we're going to do with trig functions?
Isn't it gonna just be like you know what I mean?
I don't know what you mean.
What are the words?
It's not going to be cotangent.
Secant, that's what I meant.
Secant doesn't go with sine though.
Cosecant. Cosecant.
Remember, everything needs a co. But no.
Okay.
So what do you think we do? What do you think we do first?
Well.
Don't ask me. I don't know. I'm just watching.
Math guru in the house.
I want to know what we do.
What do we do first? What do we do on the last 1, 2, 3, 4 examples? No, that's we just did them.
X equals sine.
Switch the x and the y first.
Oh,
Okay.
losing my hair.
So it's going to be x equals the sine of y, right?
Sine is it Y?
But now, for those of you that just loved it when you were trees, okay,
When were we trees?
G, I'm a tree.
Geometry?
There you go. You just got to say it fast. It's y equals
Geometry.
inverse sine
Oh,
of x.
Wow.
So, let's go unit circle here now. When we would do y equals sine of x, we would plug in an angle, and that would get us out a y value, right?
Yes.
Okay? What's the inverse sine going to do? Nope.
Angle.
It's going to give us an angle. We're going to plug in a y value. It's going to give us out an angle.
Wow.
Okay?
Wow.
Shh, don't tell anybody. All right. Now,
It's harder.
let's graph this bad boy. Let's start with what we know. We know how to graph sine, right?
Starts at 0.
Starts at
0.
low, middle, or high? Though?
Middle.
Middle. Starts at the middle.
Sorry.
Okay,
middle.
starts at the middle. Okay, then it goes which way? Middle.
It could go up if it's high.
Well, we got positives,
Okay,
yep.
so up.
So it goes up to the high, back to the middle, down to the low, back to the middle, right?
Yes.
Now, little side note, on curve fitting, formatives you'll get back a little bit later on. If this is what my curve looks like here at Big Fork, Montana, okay, and I want to use a sine curve for that, which a lot of people wanted to use a sine curve for that, and that's fine, but I have to find that middle. And that's where my starting point is. It doesn't start down here at the very first data point with the sine curve, because the sine curve wouldn't start at the low point. It starts at the middle, so I have to go over here and I got to find the middle. Or if I wanted to use a positive a-valued cosine curve, I'd have to go find the high point. Okay? If I want to use this first one on this one, I'd have to have a negative a-valued cosine curve. Okay? Because it's curve fitting. It's all that stuff that we've been doing. It's just backwards, making you think. Okay? Let me adjust this. Bring that over, bring that over, bring that over. Alright. That's right. We're still okay. So, pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi. Right? Sine, regular old sine. What is the domain of regular old sine?
All real.
What is the range of regular old sine?
-1. I'm killing it, guys.
Yeah, you
Yeah.
are.
So that means we have a maximum value, a high value of positive 1, low value of negative 1. So we said it started in the middle, then went up, back to the middle, then down, back to the middle. If I continue that backwards, it would go down, middle, up, back to the middle. Right? And it would keep waving like that. far, I'm guessing that I haven't blown the doors off of anybody yet. Because we've graphed a bunch of those before semester break. Yes?
Yes.
Love it. Okay. Now, let's go to the inverse.
Did you just flip it?
What do you mean flip it?
Yeah.
Because what's the first thing we did when we found the inverse function?
Flipped it.
We switched the x and the y, right?
Yeah.
Okay. So that means that my old x-axis is what? My new y-axis. My old y-axis
Is your new
is my
x-axis.
new x-axis. So, take that one more step further. My old domain
Is your range.
is my new range. My old range is my new domain. So down here on the inverse, I'll get to you in a second,
Okay.
my domain here now is from -1 to +1. Right?
Yeah.
My new range now is all real numbers. Right? Go for it.
Can I just make sure I'm picturing this right before you continue anymore? Instead of it being this way, it's kind of like this.
To be vertical now. Yep.
Great.
Okay. So now when we draw it,
Oh boy.
so now we're going to go here, 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 and there. And then when we draw it, now it's going to look like that and like that.
Oh, yes, sir.
Right?
Yep.
Because you were the one that told me
Mhm.
x becomes y, y becomes x. Okay? So then this now is -1. This now is +1.
This is 2 pi. And this is pi.
This is 1, and then that's pi, and then there, and then 2 pi, and then there, and then -pi, and then there at -2 pi. Right? Now, let's talk old points. Old point number 1 is origin, right? If I switch the x and the y on that, that's still the origin. Okay? Old point up here was at the point pi over 2, comma 1. Inverse point would be at 1 comma pi over 2. Right there. Next one, pi comma 0 becomes 0 comma pi. 3 pi over 2, oops, down here, 3 pi over 2 comma -1 becomes -1 comma 3 pi over 2. 2 pi comma 0 becomes 0 comma 2 pi. With me on all of that. Switching the x and the y means you can take any point and switch the x and the y.
It's beautiful.
So now it goes here, right? And so if I continued on, I'd go there, and then I'd go there, and then I'd go there, and then I'd come there, and then I'd go like this. Right? What's wrong with the inverse of sine the graph of the inverse of sine?
It's not a function.
Why is it not a function?
Because there's
Pass the
multiple
vertical
points.
line test.
Fails the VLT, fails the vertical line test.
BLT.
Okay? So the inverse sine, or x equals sine of y or y, equals the inverse sine of x is not a function. Okay, fails the vertical line test. Okay? But we can still use it. Okay? So my original
Should we write this?
was y equals the sine of x. My inverse, we have two different ways to write the inverse. First way is the tree way. Right? Angle finders, you call them in geometry.
It's gonna be like times pi or something.
What do you mean?
For the next.
For the other way of doing it?
Yes.
No, it's
Oh.
even crazier than that.
You just switch.
Or it's called arc sine. Arcsine. Arc sine
This is great.
of x.
Do our calculators do that?
They just use the inverse. They both mean the exact same
Oh,
thing. But,
duh.
yeah. But arc sine has it where it's restricted so that it is truly a function.
Oh.
Okay? And we'll get into that here momentarily. Okay? So that's our notation. Either one, we're both doing the same thing. We're gonna put in y values or put in number values, and we're gonna get out an angle. Okay? All right. Now, where do I find my answers? Because I need to have answers so that we all end up at the same location. Okay? So that we're not all we want to be in pre-calc in room 221, but not geometry down the ramp. Okay. All right. So, what we do is how we do when we do the do. Okay, oops, that's off a little bit. OCD kicking in. Oh, a little too far.
Yeah.
Close enough. It's in the box. All right. So if I want to make inverse sine or arc sine or whichever one you want to call it, if I want to make y equals the inverse sine of x become a function, I need to restrict it. And so it's still going to be from -1 to +1.
The range. The domain.
Which one do I need to restrict?
The range.
The range. So I'm going to restrict the range. So my domain is still going to be from -1 to +1. I can only put values between -1 and +1 into the inverse sine function to get out an angle. Okay? So I can only do that. But my range now, I'm going to actually take the middle portion of it. So that's going to be from -π/2 to +π/2.
That's really what it looks like?
Yeah, look at your graph.
Oh, like my axes.
Yep. So if you just went like this,
Definitely true. Aha.
it's just right there.
Okay.
Now, if we switch back to normal sine, where on the unit circle is normal sine or angles of negative pi over 2 to positive pi over 2? Where on the unit circle gives me angles of negative pi over 2 to positive pi over 2? No? Second quadrant is from pi over 2 to pi.
Right, restate your question.
Where on the unit circle are angles negative pi over 2 to positive pi over 2?
The left, yes.
The left side?
Yes.
Oh,
The angles?
Negative to positive. The angles.
Oh, the right side.
It's the right side. Because down here is
Yes.
negative pi over 2, correct?
Yes.
And then all the way up to 0, which is in that range, all the way up to positive pi over 2. So really, for inverse sine, you are looking at the right half of the unit circle. And that's where you will find all the range of values from negative 1 up to positive 1. Okay? Let's put this to work. Let's do some maths. Okay? So this is going to be an inverse trig problem. Arc sine of 1/2, or inverse sine of 1/2. It also could be written.
So that means an angle measure?
Okay. So that means our answer is going to be an
Yeah.
angle measure. Yep. We're inputting in this case, because it's sine, we're inputting a y value, looking for the angle where that y value happens.
And since
Okay? So in my brain, I'm thinking where on the right half is sine equal to 1/2.
okay.
In my brain, that's what I'm thinking. Where on the right half of the unit circle is the sine? Sine is x or sine is y? Sine is y. So where is my y value on the right half of the unit circle? 1/2.
Pi over 6.
Pi over 6. So this, because it's the y value, is 1/2.
Okay.
Okay? So this answer here is pi over 6. Right? Let's try another one. Just when you have all the answers, I go and I change the question.
Yeah, I have a question.
What's up?
What does the negative 1 do then? Does it matter?
That just tells you that you're finding the angle.
Okay.
So this is on this one, I'm thinking in my brain, I'm thinking, well, this also could be written as
Because it's on the right side, because you're using the restrictions.
where is sine equal to negative 1/2? Where? 11 pi over 6, says Logan. Would Logan be right at 11 pi over 6?
Yes.
Is Logan correct?
Yes.
I'm a
Why
little
not,
confused.
Kate? Oh, you had me and then you didn't have me.
Well, I just know it's no because of your tone of voice and the color that he used.
What does my my range of values have to be?
Between pi over 2 and
No.
negative pi.
Between negative pi over 2.
So it'd be negative pi over 6.
How do you know that?
From the restrictions.
Where are the
rate-
restrictions?
The range
Oops,
is
I almost put negative pi over 6.
Yeah, the range is negative pi over pi. Or comma pi.
No,
Yeah? Or pi over 2.
that's better.
Hold up. Let me go back to my back page. Okay, your restrictions.
I'll go back one. I'll go back a slide to show you. Okay, so the range, my answers have to be between negative pi over 2 and positive pi over 2,
How
Okay.
did you get that though?
because that's what we had to restrict our range to make it be
Oh,
a function.
Okay, yep.
Okay, with me?
So, like,
Okay.
your answers, why?
So all your answers have to be in that range.
Okay.
11 pi over 6 is outside of that range, but
Negative pi over 6.
negative pi over 6 is the same angle and it's in that range. Negative pi over 6 is the same as 11 pi over 6 and it's in my range of
So
values.
you'll either be at like pi over 6, pi over 4, pi over 3, or negative pi over 6,
Or
or pi over 4.
pi over 2.
But they'll be negative.
Okay? What I'd like you to try now is I would like you to try these 4 on your own.
I think this is easy.
Yeah.
So, number 3, I'm looking right side of the unit circle. Where is sine, my y value, root 3 over 2?
Pi over 3.
Pi over 3. So this one is pi over 3. Whoops, tap the brakes. Maybe it's not.
No,
No.
because then it breaks its restrictions.
Yep.
Of being a function.
Right side, unit circle. Where is sine 2?
No.
Right side of the unit circle, where is the y value equal to 2? Why not?
Undefined.
Why not? Why is it not 2 on the right side of the unit circle?
Your domain is negative 1 to 1.
So it's outside that domain, right? Just ask that guy right there. He's all about this. So this is not
He's like, what are we
possible.
talking about?
Did you know how to say that?
Possible. Not possible.
Not possible. Good job.
Do it.
Do it.
No possible.
We're just getting observed by everybody today.
Yeah.
Oh, really?
Galligan was in. Now you're in.
Soon Mr.
maybe
Tomsky will
something's-
be here.
Maybe.
You never know.
Wow.
There's something going on.
Well, yeah.
Trouble.
Well, yeah. Us two together, trouble. Arc sine 0. Where on the right side is sine equal to 0?
0.
It's 0.
Ha.
See?
I love it.
He is really coming in here just to observe you walk
Exactly.
Whoa.
Arc sine negative 1, or inverse sine negative 1.
Negative
Right side.
pi over
Where
2.
is it?
Negative pi over 2.
Wanna say 3 pi over 2, right?
Correct.
But that's outside that range, so it's negative pi over 2.
Yeah, let's go.
Yeah, buddy? Don't forget, tomorrow, your cosecant and cotangent graphs are due. Okay? It would help to show a little bit of work on there too, so that we know you just didn't copy it. Okay?
Brenna.